Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 14 video from the chapter of Exponents of Real Numbers, where I will discuss about a particular type of problem which is based on unique prime factorization theorem. As you can see in the thumbnail, on one side you will be given a natural number, and on the other side you will be given the product of some powers of distinct prime numbers, and we have to in most problems we have to find the unknown powers. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 14 video, where I will discuss about solving problems based on unique prime factorization theorem. Okay, so the unique prime factorization theorem says that we can that every natural number can be uniquely, so this is the foundation concept, every natural number can be uniquely expressed as a product of powers of distinct prime numbers. For example, the natural number 225 can be uniquely expressed as 5 square multiplied by 3 square. So the factors of the distinct primes, they will be unique, and the powers will also be the same. Similarly, 100 can be expressed as 5 square multiplied by 2 square, and 40,500 can be expressed as 2 square 5 multiplied by 5 cube multiplied by 3 to the power 4. Now the theorem, the next concept which is important for solving numerical problems is that let's say PQ are distinct prime numbers and ABCDEF are some natural numbers, and if there is an equation given such that P to the power A multiplied by Q to the power B multiplied by R to the power C is equal to P to the power D multiplied by Q to the power E multiplied by R to the power F, then this will imply that that the powers of the same prime numbers on both the sides will be equal. So we must have A equals to D, B equals to E, and C equals to F. Now in some problems you will know the PQR, that is the distinct primes, and you have to find some unknown powers either on the left hand side or on the right hand side, and and in some other problems the powers will be given, the powers you will know, and you have to identify the distinct primes. So these are the mostly two variations of problems based on unique prime factorization. So let's see how to apply this concept in some problems. The first problem says that if 40,500 is equal to 5 to the power x multiplied by 2 to the power y multiplied by p to the power z, where p is not equals to 5 and p is not equals to 2, then find the value of pth root of xyz. Now clearly we can see that the left hand side is a natural number, and the right hand side we can see it's a product of three numbers, three powers, 5 to the power x multiplied by 2 to the power y multiplied by p to the power z. We should clearly understand, since 5 and 2 are prime numbers, prime to each other, we should clearly understand that p will also be a prime number. We have to find p and xyz. So the primary task is to prime factorize the given number. In this case it is on the left hand side, which is 40,500. So you must be very fast in prime factorization of medium to large numbers, which I am very slow at, so please bear with me. If I divide by 5, this is 8100, and clearly this is 9900. Okay, so 100. Okay, so I can see that 40,500, if I do prime factorization, that is if I express 40,500 as a product of powers of distinct primes, it will be 5 uh, 5, okay, so there is 100 is so 10 is 2 to the 2 multiplied by 5 and 2 multiplied by 5. So clearly I can see 5 cube multiplied by 2 square and multiplied by 3 to the power 4. I hope I am right. Let me check again. 9981 is 3 to the power 4. Okay. 100 is 250, which is 225. So 2 square and 5 square. Okay, I think it's right. Okay. So 40,500 is 5 cube multiplied by 2 square multiplied by 3 to the power 4, which is given to be 5 to the power x multiplied by 2 to the power y multiplied by p to the power z. Clearly comparing the prime numbers on both the side and their powers, we can easily say that x should be equal to 3, x should be equal to 3, y should be equal to 2, p should be equal to 3, and z should be equal to 4. So now we are asked to find pth root of x sorry, x, y, z, which is, what is p? P is cube, 3. So cube root of x, y, z means 3 multiplied by 2 multiplied by 4. This is cube root of 24. Okay, so cube root of 24. So 24 is 8 multiplied by 3 and 8 is 2 cube multiplied by 3. So this is 2 cube multiplied by 3. Cube root means in the exponential form 1 by 3. So this is 2 cube raised to the power 1 by 3 multiplied by 3 raised to the power 1 by 3, which becomes 2 multiplied by 3 raised to the power 1 by 3. So 2 multiplied by 3 raised to the power 1 by 3 is the correct choice, is the answer. So C is the correct choice. Let's see the next problem. Question number 2, example 2. We have 3528 is equal to 2x plus 1 square multiplied by 2y plus 1 square multiplied by z cube, where z, 2x plus 1, 2y plus 1 are distinct prime numbers and x is greater than y. X is greater than y, then the value of x plus y plus z whole raised to the power xyz by 2 is. So clearly the first task is to prime factorize the number 3528. 3528 divided by 2 gives 1764 divided by 2 gives 882 divided by 2 gives 441. 441. Okay, so will this divide by, yes, it will divide by 3. 1 4 7, this will again divide by 3, 4 9. Okay, 7 7. So clearly 35, the prime factorization of the number 3528 is 2 cube multiplied by 3 square multiplied by 7 square. Now okay, so definitely if I compare, so this is given, 3528 is given as 2x plus 1 square multiplied by 2y plus 1 square multiplied by z cube. Comparing this and this, we can clearly say that z has to be equal to 3. The power of z, the power of 3 on the left hand side over here is 2, and on the right hand side the power of 3 is z. So z has to be equal to 2. Z has to be equal to 2, not 3 but 2. Z is 2. Okay. Now we see that there are powers of 2 times. So we see, so either 2x plus 1 has to be 3, or 2x plus 1 can also be 7. If I compare the power of 2, I see that on the right hand side, in the prime factorization, I have 3 square and 7 square, and in the given problem on the right hand side, I have 2x plus 1 square and 2y plus 1 square. So I have to distinguish whether 2x plus 1 is 3 or 7. Now it is given that x is greater than y. If x is greater than y, this will imply 2x is greater than y. That is, if I multiply both sides by 2, the inequality remains the same. Now if I add again 1 to both sides, I will have the inequality will remain same. So I will have 2x plus 1 greater than 2y plus 1. So clearly we can say that 2x plus 1 is 3 and 2y plus 1 is 7. Clearly 2x plus 1 equals to 3. Solving this linear equation, we will get x is equal to 1, and solving 2y plus 1 equals to 7, we will have y is equal to 3. So we have x equals to 1, y equals to 3, z equals to 2. Z equals to 2. Okay. Now it is asking to find x plus y plus z. So x is 1, y is 3, z is 2. So 1 plus 3 plus 2, this whole raised to the power xyz. Xyz is, xyz will be 6. So 6 divided by 2. This is equal to 1 plus 3 plus 2 is 6. 6 raised to the power 3, and this is equal to 216. 6 cube is 216. 36, yes, 216. So the correct choice is B. B is the correct choice. Let's see the next problem. If 5 to the power xy divided by 7 to the power 5x minus 8 is equal to 30625, then the value of x. Okay. Now I hope I have explained this in some earlier video what this expression actually means. You see x, in the power you see y, and then as a power of y you see x. This is actually x raised to the power, and the power is again an exponential term which is y to the power x. Okay. So clearly first I have to prime factorize 30625. 30625. Let's prime factorize this. Dividing by 5 gives 6, 30, 1, 2, 5. Again dividing by 5 we get 1, 2, 2, 5. Again dividing by 5 we get 2, 4, 5. Again dividing by 5 we get 4, 9, and this is clearly 7, 7. So 30625, the prime factorization of 30625 is 5 to the power 4 multiplied by 7 square. Now in the given equation we have to simplify a little bit. It is given 5 raised to the power x by y, and in the denominator I am having 7 raised to the power 5x minus 8. I will bring the denominator, I will bring it up. That is, it will be 7 raised to the power minus of 5x minus 8. This is equal to 5 raised to the power 4 multiplied by 7 square. Okay. Clearly, if we see on both the side we are having powers of distinct primes 5 and 7. So we can equate the powers of 5 on both the sides as well as the powers of 7 on both the sides. So we have x equating the powers of 7 on both sides, we get minus 5x minus 8 is equal to 2. I think I did a mistake. I'm really sorry for this. In the denominator it will not be 5x minus 8, but it will be 8 minus 5x. It will be 8 minus 5x. I'm sorry for this. So 8 minus 5x. So if I so this will be 8 minus 5x. So we have negative of 8 minus 5x is 2. This implies that 8 minus 5x is equal to minus 2. This implies 5x is equal to 10, and this implies x is equal to 2. So we got x is equal to 2. Also, if I equate the powers of y, I will have xy is equal to 4. This implies y is equal to 4 divided by x, which is x is equal to 2, so 4 divided by 2, which is 2. So y is also equal to 2. So now it is asking what is the value of, so now x to the power y to the power x becomes 2, 2 and 2. This is equal to 2 raised to the power, and the power is 2 raised to the power 2, which is equal to 2 raised to the power 4, and this is equal to 16. So the correct choice is D. D is the correct choice. Let's see the next problem. Okay, so we are given some equation on the left hand side. We are seeing powers of x and y, and on the right hand side also we are seeing x to the power a, y to the power b. It is given that x and y are distinct prime numbers, then the value of a plus b whole cube is. Okay, so definitely we have to first simplify the left hand side. Okay, now on the left hand side I am simplifying this by gathering all the x terms and applying the laws of exponents. So I have in the base of this term, of this exponential term, I am simplifying. I am using applying laws of exponents. I am grouping x and y. So it will be x to the power minus y minus 3 multiplied by, we have y square minus 2, and this whole raised to the power 1 by 3 divided by, similarly I will do the same thing on the for this exponential term. So we have x to the power 6 minus of minus 2 multiplied by y to the power minus 3 minus 3 whole raised to the power half is equal to x to the power a multiplied by y to the power b. Okay, so this implies, further simplifying the powers, we get x to the power minus 4 multiplied by y to the power 4, this whole raised to the power 1 by 3 divided by, we have x to the power 8 multiplied by y to the power minus 9, this whole raised to the power half is equal to x to the power a y to the power b. Okay, this implies the rational power 1 by 3, I can applying the laws of rational powers, it will be x to the power minus 4 by 3 x to the power minus 4 by 3 multiplied by y to the power 4 by 3, and so this is divided by, we have x to the power 8 by 2 multiplied by y to the power minus 9 by 2. This is equal to x to the power a multiplied by y to the power b. Again simplifying, applying the laws of exponents and gathering the similar powers of similar bases, x and y, I have on the left hand side x to the power minus 4 by 3 minus 8 by 2 is 4, so 4 multiplied by y to the power 4 by 3 plus 9 by 2 is equal to x to the power a multiplied by y to the power b. Okay. So this implies x to the power minus 16 by 3 multiplied by y to the power 27, 8, 35 by 2 is equal to, I think I have done some mistake because the powers on the left hand side are looking very weird. Let me check once again. X to the power minus 1 minus 3, okay, multiplied by y to the power 2 minus of minus 2, okay, this whole raised to the power 1 by 3 divided by x to the power 6 minus of minus 2, okay, multiplied by y to the power minus 3 whole raised to the power half, okay. So this is 6 to the power minus x to the power minus 4 multiplied by y to the power 4 whole raised to the power 1 by 3 divided by x to the power 8 multiplied by y to the power minus, sorry, this is not 9 but this is 6. This is 6. Okay. Okay. Then we have x to the power minus 4 by 3 multiplied by y to the power 4 by 3 divided by x to the power 8 by 2 multiplied by this will be 6 minus 6 by 2 equals to x to the power a y to the power b. Further simplifying the left hand side, we get x to the power minus 4 by 3 minus 4 multiplied by y to the power 4 by 3 plus this will be 3. This will be 3. This is 3 minus 3 plus 3, okay. So now we have x to the power minus 16 by 3 multiplied by y to the power, this will be 13 by 2 32, 39. I will quickly check whether I have correctly copied the question or not. I think I have done some mistake in the powers. Let me quickly check. I'm really sorry for this. Where it is? Okay, so it was x to the power minus 1 y square divided by x cube y to the power minus 2 divided by x to the power 6 y to the power minus 3 divided by x to the power minus 2. Okay, this is fine. uh, okay, so this is fine. Okay, so I did a little mistake over here. This will be 4 by 3 plus 3 is 13 by 3. 13 by 3. Okay, so now we can see that now we can, since it is given x and y are distinct prime numbers, we can equate the power of x on both the sides and the power of y. So we get a is equal to minus 16 by 3 and b is equal to 13 by 3. This implies we are asked to find a plus b whole cube. So what is a plus b? So a plus b whole cube is minus 16 by 3 plus 13 by 3 whole cube. Minus 16 by 3 plus 13 by 3 is minus 3 by 3 whole cube. This is minus 1 whole cube and this is equal to minus 1. So a plus b whole cube will be equal to minus 1. So the correct choice is B. B is the correct choice. Let's see the next problem. Example 5. For distinct prime numbers a, b, if cube root of a to the power 6 multiplied by b to the power minus 4 is equal to a to the power x multiplied by b to the power 2y, then find x by y whole cube. The concept is same. Since it is given a and b are distinct prime numbers, we have to convert the left hand side as the product of powers of a and b. So cube root of a to the power 6 multiplied by b to the power minus 4 is equal to a to the power 6 multiplied by b to the power minus 4, this whole raised to the power 1 by 3. This is equal to a to the power 6 whole raised to the power 1 by 3 multiplied by b to the power minus 4, this whole raised to the power 1 by 3. This is equal to a square multiplied by b to the power minus 4 by 3, which is given to be equal to a to the power x and b to the power 2y. Since a and b are distinct prime numbers, I can equate the powers of a and in both the sides and the powers of b from both the sides. So we get x is equal to 2 and 2y is equal to minus 4 by 3. This implies y is equal to minus 2 by 3. So we have to find x by y whole cube. X by y whole cube will be, what is x? X is 2 and what is y? Minus 2 by 3 whole cube. This after simplification becomes minus 3 whole cube. This is equal to minus of 27. So minus 27 is the answer. So choice C is the correct choice. Let's see the last problem. I think this is the last problem. Okay, so I was solving it. I'm sorry, my solution is still there. If 1176 is equal to 2x, 2x to the power a multiplied by 6y plus 1 to the power b multiplied by z plus 2 multiplied z plus 2 to the power c, where x, y, z, a, b, c are natural numbers, then the value of, okay, so the first thing is we have to prime factorize 1176. Okay, let's divide by 2. We have 5, 8, 8, then again divide by 2, 294. We have 4 and 18, 4, okay, and then divide by 3, 9, 8, divide by 7, 1, 14, divide by 7, 2. So we see the prime factorization of 1176 is equal to 2 cube multiplied by 3 to the power 1 multiplied by 7 square. Okay, now since on the right hand side in the given equation we are having 2x 6y plus 1 z plus 2. Since it is given x, y, z are all natural numbers, so obviously 2x 6y plus 1 and z plus 2, they will all be natural numbers. And okay, so now how do we find x, y and z? Now clearly 2x has to be equal to 2 because 2x is, since if x is the natural number, then 2x is always an even number, and we can see in this prime factorization of 1176 the only even prime number is 2. So clearly we can say that 2x has to be equal to 2. This implies x is equal to 1. Also equating the powers of 2 both sides, we must have a is equal to 3. Okay, now 6y plus 1, 6y, if y is a natural number, then 6y plus 1 will always be greater than equal to 7. So 6y plus 1 cannot be 3, it has to be equal to 7. So we must have 6y plus 1 equals to 7. This implies y is equal to 1. Now when we got y equals to 1, so definitely the power of, we know the prime factorization of 1176, the power of 7 is 2. So clearly we can say that b is equal to 2. So now obviously z plus 2 has to be equal to 3. This implies z is equal to 1 and c has to be equal to 1. So we have found x, y, z, a, b, c. Okay, so x is equal to 1, y is equal to 1 and z is equal to 1. So x, y, z are all 1 and a is equal to 3, b is equal to 2 and c is equal to 1. Now we have to find the given expression. We are seeing a product of 3 radicals. Now clearly we see that xy will be equal to yz will be equal to zx, they all will be equal to 1. So the given expression becomes basically second root, which is basically a square root, multiplied by second root of c multiplied by second root of b, which is nothing but square root of a multiplied by square root of b multiplied by square root of c. This is nothing but square root of a, b, c. What is a, b, c? 3 multiplied by 2 multiplied by 1. So this is square root of 6. Square root of 6. So the answer is square root of 6. So that is all for these problems. Solving these problems will give you a good idea of how to solve this kind of problems based on prime factorization, unique prime factorization of natural numbers. So these two results, theorem A and B, you should understand very well to solve this kind of problems. So if this video was beneficial, please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video I will try to discuss about solving more than one variable in an exponential equation, that is maybe x, y, maybe 2 variables x and y, or even 3 variables x, y, z. I will discuss those, how to solve those kind of problems with solving session and example problems. So please stay tuned for that. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.